Hey, what's up guys? Welcome back to another lovely SOFIA video. This one's going to be on Module 11.1, Modeling Equivalent Expressions. You should have got this from your math teacher today in class. And you're also going to need a few pages from the actual notes 11.1. So that's going to be page 293 through 296. So if you don't have all that out, go ahead and do that for me, please. Alright, so hopefully everything is out on your desk now. I want you to look at number 1 right here. It says, how many different ways can you come up with 25 cents? List them below. So my challenge to you is think of 3 different ways that you can come up with 25 cents. So pause the video and do that for me, please. Alright, so I went ahead and found 3. I said 25 pennies, 2 dimes, and a nickel, and 5 nickels. Now, they're all different ways of coming up with the same amount of money. That's kind of what we're going to be talking about today. Now, there are tons of other ones, and I'm sure that you guys have a few different ones, but in the end, they all equal 25 cents. So they're all going to be equivalent to each other. So I want you guys to kind of think about that as we go through this video and kind of keep referring to that 25 cents model to help you think about everything else. Okay, so now number 2 says, if you look at page 293, I want to look at the pictorial model. So go ahead and get out page 293 on top of these notes, please. Alright, so page 293 says modeling equivalent expressions, and just as a reminder, an equivalent expression is an expression that has the same value. So just like we talked about the cents up above, they are all different, but they represent the same value. So if we look at this scale, now that's what this is a scale. So if one side is heavier, that side would tip down, and the lighter side would go up. But if this side was heavier, it would tip down, and this side would go up. You guys have probably seen these in science classes before. But if we look at this one in particular, I've got 2 on the top and 3 on the bottom, which would give me a total of 5. On this side, I've got 1 on the top and 4 on the bottom, which again would give me 5. And that explains why my scale is even and not one side higher or lower than the other. So we're going to answer these questions just to kind of get us going for the actual work that we're going to be creating. So part A says, write an expression to represent the circles on the left side of the balance. Well, we could say that it is 2 plus 3. So I'm going to go ahead and write that. And that would give us a total of 5. B says the value of the expression on the left side is, well, the value would be if I added the 2 together, what is my answer? Which I've already told you is 5. So the value of the left side would be 5. And the expression would be 2 plus 3. So now it says write an expression to represent the circles on the right side of the balance. So if I look at that, we've got 1 on top and 4 on the bottom. So our expression would be 1 plus 4. And the value of the expression on the right side is, once again, 5. So part E says, since the expressions have the same value, the expressions are, this is a word that we've talked about quite a bit, it is equivalent. Equivalent. And F says, what will happen if you remove a circle from the right side of the balance? Well, as I mentioned before, if I take one away from the right side, this side will now have less on it. Therefore, it will be lighter than the other side, and this side will begin to fall down while this one rises up. So therefore, they will not be equivalent, and our right side would be less than the left side. Alright, so what I want you to do is go ahead and pause the video here, make sure you have all of that copied down, and then go ahead and go back to the white sheet of paper that you got in class today. Alright, number 3 on our notes from class today say, here are a few vocabulary words that I want to discuss. And if you go back to 293, one of the words is equivalent expressions, which I've got right there. And then if you turn 293 over to 294, you've got algebraic expression, variable, and constant. So what I want you to do is I want you to pause the video and copy those words down, or their definitions down, so that you're kind of thinking about it and you're hearing them, and then I'm going to go over them very quickly. So go ahead and pause the video and use page 293 and 294 to copy down those definitions. Okay, so I went ahead and wrote down some definitions for mine. An equivalent expression is an expression with the same value, which makes sense because the word equivalent means the same. Then we've got algebraic expression, and this is an expression that contains one or more variable and operation symbols. So a variable we'll talk about in just a second, and an operation symbol would be an addition sign, subtraction, multiplication, division. So it's going to have one of those, maybe more, as well as a variable, which we've talked about this last module. And a variable is a letter or symbol used to represent an unknown. That's usually the answer that we're looking for. And you can choose any letter that you want. Most of the time we see X, but A, B, C, D, Q, really doesn't matter. It's up to you. And finally, D, a constant. This is a number whose value will not change, which makes sense because the word constant means continual, consecutive. It's all going to be happening again and again and again. Alright, so now we are moving on to part 4, algebraic expressions. Now this is where we're going to take the information that we've just learned and kind of tie it into some new thought. So if you want to look at the notes to keep up with us, I'm on page 294, which you definitely don't have to, just if that will help you to visualize everything. Okay, so for part A, it says phrases to expressions. So basically what this means is you're going to have words. So for example, you might have one that says the sum of 7 and x. Now we know that the word sum means the answer to an addition problem. Now we've got our number 7 and x, which as we all know is our variable. So when we're writing from phrases to expressions, that means that it's going to give you the phrase and I want you to turn it into an expression. So what I want you to do is I want you to pause the video and try to turn the phrase, the sum of 7 and x, into an expression. So if you did that, the algebraic expression would end up being 7 plus x. Because what it's telling you is if you add 7 and x, you would get the sum, which is the answer to an addition problem. Okay, so let's try another one. Let's look at the quotient of z and 3. Alright, so just a friendly reminder, the quotient is the answer to a division problem. So therefore we know that our operation is going to be division. So go ahead and pause the video and try to set that one up for me. Alright, that's what I got. The answer of z and 3. So if I divided z by 3, that would give me my quotient. Okay, so that's 2 examples. Hopefully that's making a little bit of sense. We could ask you any type though. We could show you with subtraction, multiplication, addition, division, and we might give you a phrase and we'll ask you to convert it into an expression. Okay, now what I want you to do is look at part B, expression to phrases. Now this is exactly what it sounds like, it's just the opposite. So instead of giving you the quotient of z and 3, I would probably give you something like z over 3, and I would ask you to write it into words. So for example, I might give you 11x, and I would say, hey, give me the phrase that this comes in. And if you did that, it would look something like this. The product, which again, the product is the answer to a multiplication question. When we don't have an operation, that means that it's going to be multiplied. So it's the product of 11 and x. Okay, so I'm going to give you another one just to let you try it for a second. So go ahead and copy this one down. 8 minus y. Alright, pause the video and try to write that expression into a phrase. Okay, so what I came up with is y less than 8, because if 8 is my number and it's 8 minus y, that means whatever I plug in for y would be 8, or would be y less than 8. So if I plugged a 2 in for that, it would be 8 minus 2, or 2 less than 8. Alright, perfect. Now, one last takeaway I want to add before we move to our last part of part 5 is 11x is the exact same thing of the product and 11x. So those two would be the same thing or equivalent. Now I want you to realize that just like our coin thing back at the top, they're all represented differently, but they all mean the same thing. So down here again, 7 plus x is the exact same thing as saying the sum of 7 and x. So I just want you guys to make sure you're thinking about that through these notes. Okay, and for the last part, I want you guys to actually take out page 295, and we're going to look at the your turn down here at the bottom. Okay, so go ahead and take out 295 and go to the very bottom at number 7 and 8 for me, please. Alright, so if we look at this bar model right here, this is just another way that we can represent equivalent algebraic expressions. So we're going to have our expression up here, and then we're going to draw it on this bar so that they're equivalent and they really mean the same thing. So if I tell you that this entire piece right here is t. The entire bar is t. And I want to take away 2. That means I have to take away 2 sections of this bar. So the entire piece is t, and we need to take away 2 pieces. So what I'm going to do is I'm going to draw 2 little pieces. That's going to represent my 2. Now, what we want to know is what's left of this. And it's kind of like going back to our first page and looking at what we had when we wrote it into an expression. This new piece is no longer just t because I've taken away 2 pieces. It's now t minus 2. Okay? So the whole thing is originally t, but I'm taking away 2 pieces, so the rest of it becomes t minus 2. And if I added back those 2 pieces, so if I erase these 2 lines, this becomes the full t again. Whatever we put on the top of the bar has to equal what's on the bottom of the bar. So t is the whole thing, t minus 2 is what's left after I remove 2. Okay, so let's look at number 8 very quickly. And I'm going to tell you that this entire piece right here is 4y. The entire thing is 4y. So what that means is inside this bar there are 4 different y's. So that means I've got to break up my bar into 4 sections. So if this makes up 4 y's, that would mean that every single one of these little boxes is equal to y. Because if I count them up, there's 1, 2, 3, and 4. So 1y, 2y, 3y, and 4y. Alright guys, so that kind of ties up the rest of it. Hopefully this helps. The Google Doc is available and ready. Please do your best on it. We will answer any questions and go over the Google Doc tomorrow in class. Have a wonderful night. We'll see you then.